Right, today I want to talk about some of the supersmart theory. It's partially some of the superspice formalisms to construct the superfield, which is some of the um, multiplicity of the SM particles around the super partner. And it refers to the introductions to the supersymmetries written by the Miller-Keston. So before they are explaining about supersymmetry formalisms, I want to talk about some of the Grassmann's variable, which is an anticommutative, satisfy the anticommutative identity, and we can define some of the Grassmann differentiations as a partials Grassmann variables that are I. Similarly, we can define the setup R, which is some right-handed Grassmann variables corresponding to the bars right-handed spinner. And there are some specific identities related about this Grassmann differentials, such as partial i's setup is equal to the Kronecker delta, because that's a discrete variable, and partial i's and the setup with the lower index is equal to the epsilon bi, which is the antisymmetric logarithm lowering matrix, because such as the lowering setup is can be lowering index of the setup P can be obtained by the setup V C if at that setup V. So there will be some delta will be appears from the birth identity, so we can prove about it. Also, epsilon's IV socializing indexes of the Grassmann differentials to make some of the minus sign, because there are some such as some of the proof for the left hand side. Such epsilon IVs act on the some Grassmann variables set of C's that equal to the epsilon IC, because there is some Kronecker deltas from the birth identity. At the right hand side, minus the partials I set of C's are equal to the epsilon I from the second identity, and it is equal to the minus epsilon IC, which is this antisymmetric identities of the epsilon matrix. And that is some of this discussion about the Grassmann differentiation. And we can consider about superspace from the such as the 4-dimensional space times, adding sort of the two Grassmann variables and the two additional Grassmann variables with the bar notations and that index, which is represented as the right-handed y spinner. And we can introduce sort of the supersymmetric transformations near the identities with exponentials from sort of the V algebra. There are maybe some generators of the momentum and the supercharge and the supercharge bar, and there will be the parameters of the space-time and the Grassmann variables, and that's called as supersymmetric transformations. And we can define sort of the superfield on the superspace as a functions of the space-time arcs and the Grassmann variable theta and theta bar, and we can expand the superfields with x and the theta. But there will be some of the finite terms in this expansion, because the theta scale is equal to the 0, because there will be the anti-commutative properties of the Grassmann variable. For example, theta 1, theta 2 is equal to the theta minus theta 2 and theta 1. So there will be some only finite terms during the expansion of the superfields, and there will be also some quadratic term. It is denoted as theta theta. That is not equal to the theta scales. It is defined as a theta I in the lower induct, and the theta is the upper induct, and a contraction between them. So there will be the theta ones, lower and upper induct, and the theta 2 and theta 2. So the summations are equal to the quadratic term. So such as the possible quadratics or terms is located in expansions, and there will be some of the matrix for the spinner. There will be some contractions between these vector fields and such a matrix in the expansions. And such as it's in the expansions, they call the component B's of the superfields. And if we give some of the specific constraints, such a superfields becomes the Kara superfields and the vector superfield. The color superfield has a spin 1 and the spin 1/2. And the vector superfield case, it has the spin 1/2 and spin 1s. So there are some of the super particles and some standard particles in the standard model, and the minimal superspace standard models can be constructed by such a superfield, and also we can construct the Lagrangians too. So if we act on such as superfields for the supersymmetric transformation, so there will be some superfields and acting on the supersymmetric transformations, and there will be some of the conjugates act on the superfields, and there will be some of the moves of the parameters of superfields with such a term. So with the dimension analysis, acts as -1 mass dimensions, and there will be the set has m-1/2 mass dimensions, and there are most -1/2. So such I sigma alpha has some m-1 dimension. So dimensions analysis the constants, and the constant with the such parameters of X, and such I the minus I, such a complex conjugate terms provides the real numbers for the space time. But there will be this additional parameter shift for the Grassmann variables to appear. And we can prove sort of the such superfield transformations with some of the reference point or configuration point. If we starting in some specific point x0, set 0, and the set 0, and if we acting sort of on the such as supersymmetry transformations as a conjugate form, then we can prove sort of the such moving sort of the parameters of the x and the status in terms of the alphas and some other terms using of the exponential and exponential b formula, which is the we are some of the formula. And also we can define of the impedance Haussmann transformation. That is similar process in the quantum mechanics to derive sort of the momentums of brightness as the differentials set into position basis. And there will be some transformed superfield minus the original superfield is at such a form. And we already know that there are some of the variable or parameter shifts with the alpha. Then we can know that there will be some of the such a term will appear. This term from here and this term from here. So that's a very similar process in the quantum mechanics. And from that, so we can expand this sort of the such exponentials, the forms of the supersymmetric transformations with the generator, so in the order of the such order of the alpha scales the omitted here. And if we compare sort of the previous formula, then we can find the supercharge as a differential flight. So this is a very similar process. In the quantum mechanics, there will be the exponentials IPX. Now we expand this as a exponential IPX. This otherwise there are some transformation, and the transformations after the sort of wave function is equal to the x0 minus x as a translation, and we can expand this as a size 1 minus ddx size. So we can know that the p is proportional to the ddx. And similarly, the supercharge as generated is proportional to the dd status as a Grassmann variable. There's a very similar process of the quantum mechanics. So the conclusion, so we have signed sort of the supercharge in terms of the differential flighter, such as set i's that we defined, set partial status, that are the Grassmann differentials, and there are some additional terms with the p's from these previous two formula. So somebody compare with between some both formula, we can have some the supercharge and the supercharge of the Q bar, and the other some of the supercharge and the branches of brighter form. And in the finals, I want to mention thing about some in the translations, like such a translation. of the translation of the space-time, such as some of the complicated Supercharge can be simplified based on the Grassmann differentiation. For example, in the such basis with some space-time shifts, then the Qi is represented like that. But the Q bar is the more more complicated form. But in the case of other basis with the minus parameter 6, then the Q bar, so simplified just the Grassmann differentiation, additional terms will be appear, but does was for the QIs. Supercharged more complicated terms, and we can use some of each supercharged in the each devices. And in partners, I want to mention about some of the covariance derivative, which is the invariance on the supersymmetric transformation commutative between the covariance, color covariant derivative and the supersymmetric transformation is equal to the zeros, and such a definition. Covariant derivatives satisfies this thing. And also we can define sort of the covariant derivatives in the upper index and the bar and the dots index thing. And such a covariant derivatives will be used to define sort of the color shape of fields. Let us start that there are some color shape of fields and there are some various component field. And if we use sort of such a color covariance derivatives as a constraint of the shape of fields, and we can remove sort of the some component field, and it will remain only spin 0 and spin 1/2 will remain, and it will go the color shape of fields. Maybe it will be discussed in the next time.